This video is about solving systems of equations using the method of elimination. So we've talked about solving systems by graphing and using our calculator. We've talked about substitution, which is algebraic, and now elimination, which is also algebraic. Pause this video to write down the steps for the elimination method. The elimination method, the first step is to multiply one or both of the equations by a number to result in two equations that contain the same or opposite term. 2. Add or subtract the equations, eliminating one variable. Then solve the equation. 3. Substitute to solve for the other variable. Let's take a look at an example. We have 5x plus 3y equal to negative 19, and 8x plus 3y equals negative 25. So this is a system of equations, and we need to find the solution. And the solution to a system of equations is a coordinate point. It's the point that the two lines intersect. So for following our elimination method steps, our first step would be to multiply one or both equations by a number to result in the two equations that have the same or opposite terms. So what that means, what all that mumbo jumbo means, is we want to look at our equations and see if we have a common term already. And in this one, we have 3y's and 3y's. So we don't actually have to multiply by anything because we already have a same term. If we were to use the substitution method, if you notice, if we were to solve for y in either one of these equations or solve for x, we would have to have fractions, and fractions are the worst. And so if we don't have to have fractions, then let's not have fractions. So using elimination, we already have the same term in both of the equations. We don't have to do any multiplying, which is fantastic. So now that we have the same term, our second step would be to add or subtract the equations so that we eliminate one of the variables, hence elimination method. So if we take 3y minus 3y, we get nothing, right? That's the point. So let's go ahead and do that. So we're going to take these two equations and we're going to subtract them. Okay? So if we have 5x minus 8x, we get a negative 3x's. 3y minus 3y is 0, right? Beautiful. And negative 19 minus a negative 25 is really like adding. When you minus a negative is adding. So negative 19 plus 25 gives us a positive 6. Beautiful. Now we just have to solve the equation. We need to solve for x because we have an x in there. So we have negative 3x equal to 6. Divide by negative 3. Divide by negative 3. X is equal to negative 2. But we're not done yet because our solution is a coordinate point, not just an x, not just a y, it's the combination. So we're going to take this x equal to negative 2. And our third step in the elimination method is to substitute now for the other variable. So we can take 5. We can take 5 times negative 2 for x, right? Plus 3y equals negative 19. If you notice, we don't have an x in there now, so we're going to go ahead and solve for y. So 5 times negative 2 is negative 10, plus 3y equal to negative 19. Add 10 to both sides. 3y equal to negative 9. Divide by 3, y is equal to negative 3. So now we have our solution. We have that coordinate point. So our solution is where x is negative 2 and our y is negative 3. So let's take a look at what we just did here. We had a system of equations, and we wanted to eliminate one of the variables. And we did that by subtracting one equation from the other equation. And that eliminated our y's. We got rid of our y's. No more y's. And then we just went ahead and solved for x. Yes. And then take that x that we just solved for and substitute it back in to find our y. And now we have our point, -2, -3. Let's look at another example. So we have this system of equations, 2x minus 9y equal to 34, and -2x plus 6y equal to -28. So we take a look at this, and we notice that our x's are both with a coefficient of 2, positive or negative, right? So we're going to try to eliminate the x's. Okay, so if we have a positive 2 and a -2, all we need to do is just add those together to get 0, right? Because if you're at positive 2 and you subtract 2, you're at 0. So we're going to go ahead and add these equations. We're going to add them this time. So positive 2 minus 2 is a whole lot of nothing. We've got -9y's plus 6y's. We have -3y's. And we have 34 minus 28, which gives us 6. Now we need to solve for y. Our second step is to go ahead and solve for y. We've eliminated our x's, so we divide by a -3. Divide by -3. Y is equal to -2. Awesome. Now we have our y, but we also need the x. So we'll take this y and plug it into just one of the equations. It doesn't matter which one, because we know that they both have the same x for the same y, because that's where they intersect. So we take 2x minus 9 times our -2 that we just found equals 34. Bring our 2x's down. -9 times -2 is a positive 18 equals 34. Then we subtract 18 from both sides. Left with 2x equal to 16. X is still not alone, so we divide by 2. Divide by 2. X is equal to 8. So now we have our x and our y, and we write it as a coordinate point, because that is our solution. 8, -2. So now I want you to try these two problems on your own. You're going to solve these systems of equations. You're going to get a coordinate point, right? Because the solution to a system of equations is the point that they intersect. So the x and y where they intersect. When I check your homework tomorrow, I'll be checking that you have both of these problems done and showing your work using the elimination method. After doing some problems with substitution and some problems with elimination, you may decide, hey, I really like substitution better than eliminations, or hey, I really like elimination better than substitution. That is, either way is totally fine with me. I don't care which way that you do it as long as you get the right answer. There's a lot of ways that you can solve math problems, and as long as you are doing it correctly and coming up with the right answer, you may choose whatever is easier for you. Sometimes, however, I will say this, sometimes certain problems are easier to do using elimination, and sometimes problems are easier to do using substitution. So either way, you can just decide, I'm going to always do it this way, or you can decide, oh, sometimes problems are easier using one or the other, so I'm just going to learn both and learn when to use them and when not to use them. It is up to you.